In this second part of this video on sketching using the general quadratic formula, we're going to explore even further and actually get a graph for our function. If you haven't already watched part 1, then make sure you go and find that. This, though, is part 2 of sketching using general quadratic formula. So we're asked to sketch this, and we know with sketching we need x-intercept, we need y-intercept, and we need a turning point. They're the features that you need and the ones that you join up to make your graph. In this type of calculation, because we're asked to use a GQF, we're going to use that to get us our x-intercepts. So write out your rule and substitute the A, the B and the C from your trinomial. So minus B becomes minus 4 plus or minus the square root of 4 squared minus 4 by A, which is 2, by C, which is minus 3, all over 2 lots of A, which is 2. So neatening all that up, 4 squared is 16, 4 times 2 is 8, 8 times 3 is 24. I've got a minus times another minus, so I have a plus 24 on 2 times 2, which is 4. Minus 4 plus or minus the square root of 40 over 4. Don't be tempted to just cancel this 4 out with that 4 though, because you need to also take into account this term over here. I'm going to write root 40. If you recall our work with surds, root 40 is root 4 by 10. Square root of 4 is 2 root 10. You need to be able to cancel your surds down in this instance. So continuing on, we have x equals minus 4 plus or minus 2 root 10 over 4. To help us cancel down and to see what's going on, I'm going to take a common factor of 2 out from the numerator there. So I have this. I can then cancel that to, oh sorry, that should be a 4 there. But I can now cancel that 2 with 2 from the denominator there. So my x-intercepts are minus 2 plus or minus root 10 on 2. Now you can work with exact values here and work out that root 10 is 3 and a bit and try to, around about 3, and try to work out where you would place those on the axis. But for now, you can use your calculator to help you. And you should find that if you do minus 2 plus root 10 over 2 and minus 2 minus root 10 over 2, you should get answers of 0.58 and minus 2.58. So that will help you in placing them on the axis. So there's our two x-intercepts. We've now got to find our turning point. So we've done that bit. Now got to find the turning point and the y-intercept, and that they should be a little bit easier. So let's have a look. 2x squared plus 4x minus 3. For our turning point, we need the axis of symmetry, which is minus b over 2a. So I have minus 4 over 2a, which is minus 1. So my x value of my turning point is at minus 1. And we substitute that back into our equation for y. So 2x squared plus 4x minus 3. Minus 1 squared is 1 times 2. I've got 2. 4 times minus 1 is minus 4 minus 3. 2 take 4 is minus 2. Take away another 3 is minus 5. So my turning point is minus 1 minus 5. I've left the easy bit to last, the y-intercept. We make x equals 0. So y is minus 3. So y-intercept, turning point, axis intercepts, the x-axis intercepts. So now we've just got to put those all together in a graph. I'll just insert another page. So we had x-intercepts of 0.58 and negative 2.58. We had y-intercept of 0 minus 5. And we had a turning point of minus 1 minus 5. So put it all together. Minus 1 minus 5 is my turning point. Minus 3, which would be around about there, is my y-intercept. Sorry, I think I've put, it should be a minus 3 up there. And then my x-intercepts of 0.58 and minus 2.58, keeping in mind that that there is our axis of symmetry. We've got 0.58 and minus 1 minus 2, 0.58. So there's all our points. Join that up, join that up. Arrows on everything, label your axis. And you're done. Oh, I didn't label that one, minus 2.58. Let's have a look at one more quick example. If I wanted to sketch this one, let's follow that same procedure. To get my x-intercepts, I'm going to use my GQF. So I have minus 6 plus or minus the square root of b squared minus 4ac all over 2a. Minus 6 is plus 6, plus or minus the square root of minus 6 squared is still 36, a positive 36. And I'm taking away 12 times 5, which is minus 60, all over 6. Now what you should notice here is that if you do this, 36 takes 60, you're going to get a negative number. If you were to continue on here, I'm going to get minus 24 in there. A negative number under the square root you cannot do. There's no solutions. Which means that our graph sits up above the x-axis. We could have shortcut this whole process if we checked at the start for what our discriminant is, because the discriminant is just that bit under the square root. Our discriminant is less than 0, therefore no solutions. So we could have shortcut having to do that and that by just working out our discriminant from the start. But never mind, we've worked out that we've got no solutions. We can keep going though. Let's just put another page in. I think I already have one here. So I know that I have no x-intercepts. My y-intercept, make x equals 0 from my equation, which I'll just write out again, was 3x squared, take 6x plus 5. If x equals 0, y equals 5. So I've got a y-intercept of 0, 5. My turning point, to find my axis of symmetry, I do minus b over 2a. So I'm going to have minus 6, which is positive 6 over 6 equals 1. Substitute x equals 1. I get y equals 3x squared minus 6x plus 5. 3 take 6 plus 5 is 2. So my turning point when x is 1, y is 2. And that's all I need now to be able to sketch my graph. 1, 2, there's my turning point. And my y-intercept is 5. 2, 4, 5 can be up here. There's my point 5. So now just come down and join everything up. It's quite a thin parabola, but there it is. X, Y, turning point labelled, y-intercept labelled. And that's it.